Hello friends, I am a cloud solutions architect at Microsoft who like making LeetCode videos, and today we are going to solve an awesome problem called Jump Game 2. If we see some of the popular companies who have already asked this question, there are companies like Amazon, Google, Goldman Sachs, Bloomberg, DoorDash, Uber, Microsoft, Apple, Tesla, TikTok, Snapchat and ByteDance. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also very well like problem on LeetCode. Basically in this problem we are given an array of integer called nums as an input, and we are told that we are initially positioned at the first position inside this given array. Now our aim in this problem is to return the minimum number of jumps required to reach to the last position. Now you must ask that how are we going to make these jumps? What are the criteria for that? So the criteria for any jump is that any given value that is presented inside this given array represents the number of values it can jump. So basically if this one is represented 2, we can say that it can reach, it can either take like one jump or it can take 2 jumps and reach to these positions, and our aim is to reach this last position, and basically we need to do this in the minimum number of jumps that is required. Now if you are confused, don't be. I'm actually going to show you a couple of examples to understand that how things work. So basically over here we are given 5 different values, and for these 5 different values, as I mentioned earlier, every single value represents the maximum number of jumps it can take. So this value number 2 has 2 possibilities. It can either take 1 jump and reach to this position number 3, or it can take 2 jumps and reach to this position number 1. Same goes with value number 3. It has 3 options. It can take like 1 jump, 2 jump or 3 jumps, and then do that. And our aim is to reach the last position from the first position in the minimum number of jumps possible. So if we see in this example, the answer is actually quite evident. We start our position at this value number 2, and if we just take like first jump to reach to this value number 3, okay, so currently the number of jumps we have taken is 1. Now from this value number 3, if we take another jump of the size 3, basically we would be able to reach to the end position, and in total we are only taking 2 jumps to reach to the end. So basically we need to return 2 as the answer in this case. If we try to understand the second examples, things are a little bit different. So in this case we can only take 1 jump. So okay, so currently the number of jumps we have taken is 1. Now from this 1 we need to take one more jump to reach to this position. So again the number of jumps we have taken so far is 2. Now from this 2 we have 2 options. Either we can take 1 jump and reach over here, but that is not the most optimal way. Most optimal way is we take a jump of 2 steps and reach to directly to this end point. So basically the answer in this case is going to be 3, that we need minimum 3 jumps to reach to this last position, and in this case we need minimum 2 jumps to reach to this last position. So this is what the problem is asking us to find, and I know it can look tricky, but it's really simple to do it. And let me show you a couple of different approaches to solve this problem. Okay, so the first approach that comes to our mind is a brute force approach, and in the brute force approach basically we are just going to use the simple logic. The logic is that at any single position we will try to see that how many jumps it can take, and try to explore all the possibilities and try to find that how many jumps it takes to reach to the end element, and also have like a minimum variable in mind that whenever we find minimum number of jumps we will keep on adding it over here, and eventually when we compute all the calculations we should have a result. So in this case what we are going to do is that okay, this value is 2. So first we will consider the possibility of just taking 1 jump. So in this case, okay, if we take 1 jump we reach over here. Again we have 3 possibilities over here, but we are only going to take 1 jump. So again we reach over here. Again this only has 1 possibility, so we reach over here and then we reach to the end. So in this case we took in total 5 jumps to reach to the end. Now secondly we are going to take like different things. So first we will take 2 jumps. So we took 2 jumps, and now we take 1 jump every single time and try to see how when we reach to the end, and so on and so forth. We keep on repeating the same process with different combinations. Now just by the explanation you can imagine that how complicated it's gonna make things, because for every single time you will have to calculate different permutations and combinations of sums, and eventually it's gonna lead to very disastrous results. Like if we see time complexity in this case, it's gonna be in the order of n factorial, because for every single element we will have to compute the process for all the other elements, and that is going to be in the order of big O of n factorial, which is really bad. So we will have to find a better solution, and the better solution is actually quite simple. So let me just directly go to the optimal solution. And now for the optimal solution, we are actually going to use a very interesting concept called greedy concept. And basically we are going to try to make the biggest jump possible every single time and try to see that where does that leads us. Now being greedy is not good in real life, but in computer science it is like the must thing, so you have to do it. Now for the greedy approach, we are actually going to keep track of 4 different variables. So first variable we are going to keep track of is the index value we are currently at. So let's just name it as index. Again, we will also have to keep track of the number of jumps we have made so far. Also we will need a variable to keep track of current maximum variable that we have been able to reach, or current maximum value we have been able to reach. And also from the current index, we will have to keep track of that what is the current end value we can reach at. So there are 4 variables. Let me go over them again. First one is the index value. Second one is the number of jumps we have made so far. These two are sensible. Third one is to keep track of that what is the current maximum value we have achieved so far, and we will only update it when we find like a better maximum value. When we go through the example, everything will make more sense. And the current end defines it is in correlation with the index value, that where does the current end lies, and if we are at the index value, then we will have to make some changes. So now let's look at the example, and currently let's initially assign the values. So initially the number of jumps are 0, current maximum is also 0, and current end is also 0. Now we start our journey. So first we come up at this first index. So whenever we are at the first index, okay, the index value currently is 0. Now the index value is 0. Now let's just keep on updating these values, right? So currently this has value number 1. So if this has value number 1, which means that this 0th index has the potential to reach maximum at the first index, which means the current maximum value we can achieve is that, okay, this current value is 0. Now over here it says that it has maximum potential to reach index value number 1. So 1 is definitely greater than 0. So because it is greater than 0, we will update the value of current maximum to 1, that okay, this is the maximum value we have been able to achieve. Now the interesting part comes. The current end we were at, the current end was 0 because we were at the 0th position, and also the index value we were at was also 0. So because both of these values were same, which means that in order to get ahead to the next index, which is not the last index, again remember I am repeating, in order to get ahead from the current index, which is not the last index, we will have to update the current end, because currently the current end was also here and the maximum value was also here, but this has the value 1, so we have the ability to go to the next, which means the current end needs to be updated. And whenever both of these are at the same place, that means if we are updating the current end value, we will only update the current end value in the condition when we are making the jump. So again, let's just go back to our analysis. Because the index value and the current end both were same, so because these two values were same, we can define that we need to update their values, which means we are taking a jump. So okay, so we made a jump, so we will do jump plus plus, so currently this value becomes 1. But the thing is, where do we update this current end to? We will always go this current end to the whatever the maximum value we have been able to find so far. So current maximum we found is 1. So again, we are going to include this value number 1 over here. Now let me clean this up a bit. So now we are at index position number 1. So we will update our index value. So our current index value is 1. Now at this position, what is the maximum it can travel? Maximum it can travel 3 points. So 3 is going to be 1 plus 3, so that is 4. So now this is the current maximum we can achieve, that is 4. So we will compare 4 with the current maximum we had. Current maximum is 1, so 4 is definitely greater than 1, which means it is sensible for us to update the current maximum. So current maximum becomes 4. Now we will also have to check that what is the current end. Now current end is still same as the index value, because this was the current end, so which means that anyways we will have to make a jump. So because we are making a jump, we will update the value over here. So currently the number of jumps we have made so far is 2, and we will also have to update the value of the current end. So current end we can reach is position number 4, because we already established that that is where the maximum number of jumps we can take. So okay, we are good up until this point. Now again, let's make the changes. So now we are at index number 2. So let's see that what story happens at index number 2. Now index number 2, the maximum we can take jump is 1. So if we take one jump, we reach at index number 3. But the thing is, if we check the current max is already 4, and the maximum we can reach is 3. So 3 is actually less than 4. So in this case, we don't need to update the current max. Okay, awesome. We are not updating the current max. And now we check, okay, current end is 4 and the index value is 2. So these two are not same. Because these two are not same, we don't need to update the current end or the number of jumps that we are taking. Now, okay, now our index value keeps on updating because we are checking this for every single index value. So now we are at position number 3. So now at position number 3, we have maximum 3 possibilities, right? So if we go to 3 steps, we reach to the index number 6. So our current maximum will become 6 because definitely 6 is greater than 4. Now we updated our current maximum. Now we also need to check few other things. Okay, so current end and index value, these two are not same. So we are not going to do any changes for now. So now our index value becomes 4. So let's update this. Okay, so this becomes 4. Now we are at this 4th position. This only has possibility of 1. So this will reach to the maximum of 5, but 5 is actually less than 6. So in this case, we will not update the current maximum. Now in this case, the index value and current end is both of them are same. So because both of them are same, we will have to do the update. So now when we do the update, okay, we are going to mark the current end as 6 because that is what the current maximum we have been able to achieve. And also the number of jumps we are going to take is going to become 3. Okay, now again we keep on repeating the same process. So again our index value becomes 5. Now because with the 5 index value, the maximum we can take is 1. So that is going to lead up to 6 but we already have current maximum at 6, so we don't need to do anything. And these two values are not same, so we are not going to do anything. Now the index value is at position number 6. Now at position number 6, we are actually able to reach to the end with just a single jump. So we are going to do that. Okay, now we reach to the end of this jump, but the thing is, we are just going to, for the sake of simplicity, go ahead with this calculation. So the current maximum we have been able to achieve is going to be 7. That is the end. Now current end and the index value, both of these are same. So because both of these are same, we will have to update our number of jumps that we need to take, and also we need to update the current end. So current end in this case is going to be 7, and we are going to check that if the current end reaches to the last position or the size of the array, that means that is the answer, and we can break out of the loop, and whatever the answer we have been able to find, we can simply return this. So in this case, for this example, the answer is going to be 4 that we can return simply. And this is the most beautiful approach of the greedy solution that I have seen so far. Now if we see time and space complexity, in this case the time complexity is so good because we are only going through every single values and calculating, keeping track of 4 different variables. So time complexity is actually going to be big O of n. So notice that from big O of n factorial, we were able to bring it down to big O of n, and all due to the greedy approach that we took. If we see space complexity, in this case the space complexity is actually going to be big O of 1 or constant space. Why? Because we are not using anything else apart from like these 4 values. So that is also a wonderful news. Okay, so let's initialize 3 variables that we need. That is going to be jump, current end, and current maximum. And initially all the values are going to be 0. Now notice that I'm not using the index value over here, and that is because we can actually use it from our loop directly. Now let's run a for loop to iterate over the given input array. So now every single time we will check that what is the current maximum we have been able to achieve. So we are basically going to compare the maximum value amongst the existing current maximum value or the value of I plus whatever the value of nums of I for that particular I is, and whichever is maximum, we are going to put it in the current maximum. Now we are also going to check one very critical condition, that if the given I is actually equal to the current end we are at. If that is the case, which means we will have to update the value of the jump. So we will do jump plus plus, and we will also have to update the value of the current end. So current end is in this case going to become the current maximum that we have been able to achieve. And believe it or not, but this concludes the whole solution. After we get out of the loop, we can simply return the jump that we have been able to find, and this should be it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And if we submit it, this is beating like almost 99.99% of the solutions in terms of time complexity, and in terms of space complexity, this is also very efficient. So this is a very good solution. And if you see, we are just only using a single loop and just like few lines of code to solve this problem. And I would be posting this in the comments, so you can check it out from there. Thank you.